In this video, I am going to solve this problem where it's given that phi of x is equal to x square minus 4x and a matrix A is given. Then we need to find the phi of A minus 5 times I, where I is the identity matrix. Okay? So that's what the problem is. To solve the problem, I'm just gonna apply the function definition first and then do the corresponding calculations. So phi of A minus 5 times I, the identity matrix, is gonna be equal to, look, phi of x, we have defined phi of x as x square minus 4x. In exactly the same way, we are gonna have phi of A is equal to a square minus 4 times A, because I'm replacing x by a matrix. So this x is being replaced by this matrix A. Then minus 5i. Okay, 5i. Now, if you look at this, you notice that for A, I can find that value. Just take this matrix A and multiply it by 4, and take the identity matrix I, multiply it by 5. However, I need to find A square. That means I need to find the square of this matrix. So that's the calculation part here. So this is what I am gonna do. Note that A square is the same as A times A, which, by the way, is nothing but just this matrix multiplied with itself. So what I am going to do, I'm just going to do the usual matrix multiplication. Take the first row, okay, so take the first row and multiply it by the first column to get the first entry, right? So if I do that, I get the following. So I will have, so let me do it on the side for your understanding. I'm going to have 1 times 1 plus 2 times 2 plus 2 times 2. So look, my first row is 1, 2, 2, and first column is also 1, 2, 2. Okay, so if I multiply the corresponding terms, corresponding entries, and then add them up, this is what I get. So it's going to be 1 times 1 is 1, 2 times 2 is 4, plus 2 times 2 is 4. So 4 plus 4 plus 1 is 9. So my first entry is going to be 9. Now let me do another calculation here. I'm going to do the first row and second column. So that's going to give me the next entry here. So it's going to be 1, 2, 2. Multiply it with the second column, which is 2, 1, 2, 2, 1, 2. So if I multiply it out, it's going to give me 1 times 2 plus 2 times 1 plus 2 times 2. Please note I'm multiplying this with this and adding that to the product of this times this, and then adding that to the product of 2 times 2. If I simplify it, 2 times 1 is 2 plus 2 times 1 is 2 plus 2 times 2 is 4. So 2 plus 2 plus 4 is equal to 8. So this is going to be 8. Now, if I continue this process, I'm going to get the new matrix, which is going to be my A square. If I do all the calculations, then this is the matrix I'm going to get. That's going to be my A square. It's going to be 988, 898, 889. Now I have A square, and then I have A and 5i, A and I, so here and here. So all I have to do is take this value and plug it into this. So let me go ahead and do this. My A square is going to be just this matrix, 9, 8, 8, 8, 9, 8, 8, 8, 9. That's my A square. Okay, so let me just write it here for clarity. A square minus 4a minus 5i. Okay, that's gonna be equal to, so this matrix, which is A square, okay, minus 4 times A. A is already something I know, which is right here. 1, 2, 2, 2, 1, 2, 2, 2, 1. Okay, minus 5i. 5 times I. Now this is a 3 by 3 matrix, so the identity matrix is going to be 1 0 0 0 1 0 0 0 1. Okay. Now what I'm going to do, I'm going to do the following. I'm just going to take this 4 and multiply this matrix by 4 every entry. Take this 5 and multiply every entry in this matrix by 5. As you can see, the 5s kind of show up along the diagonal. Now this matrix minus this matrix, okay, this is negative here, so two negatives, right? So in essence, I could rewrite it this way. So what I have done here is this. Look, this is a minus sign and this is a minus sign. So in essence, what you're doing is you're doing something like this: negative 5 minus 4, which is going to be what? You add the 5 and the 4 and put a negative sign in front of it, right? So it's going to be 5 plus 4 is 9. Since this is subtraction, so both of them have negative sign in front of them, you just put it that way. That's exactly what I have done. Look, here what I have done is this: 4 plus 5 is going to be 9. That's my 9. Then 8 plus 0 is 8. 8 plus 0 is 8. Okay. Then 8 is here, 8 plus 0. Then look, 4 plus 5 is 9. And similarly 4 plus 5 is 9. Look, along the diagonal the entries change. Okay, these 4s are being added to the 5s here. Okay, 4 plus 5 is 9. So this is the new matrix I get, and there is a negative sign in front because this one has negative, this one has negative. So you are in essence adding two matrices that have negative in front of them. Now, however, look what happens. This matrix and this matrix is exactly the same. So you are subtracting one matrix from another which happens to be the same matrix. Now your answer is going to be then finally not 0. Be careful here. It's not 0, but rather 0 matrix. There is a difference between 0 and 0 matrix. A typical mistake students make when they do this kind of calculations, they say, okay, this minus this, it's the same thing I'm subtracting from. Okay, so it's going to be a matrix A, let's say, minus matrix A. That's not just 0, but it's a 0 matrix. Okay, this is a matrix itself. So in exactly the same way, this minus this is a 0 matrix. That's what we've got. Now let me summarize what I did for you. Okay, so we were given the following. We are given a function phi of x is equal to x square minus 4x, and we are given a matrix A is equal to this. We need to evaluate or find the value of phi of A minus 5i. Phi of A, just by applying the definition, we get a square minus 4a minus 5i. Okay, then minus 5i is this minus 5i. Now this one comes from the definition of phi of x. Now we have a and we have I, so we don't need to worry about those, but we need to find a square, and I just find a square for you right here. If you multiply a with itself, that means you're multiplying the given matrix A with itself using the multiplication definition of matrices, we get this matrix. Then I just plug it in here, a square minus 4a minus 5i, and then if I keep going, then what happens is that I get the following, basically 0 at the end after doing some algebraic manipulation. Okay, so this is the step basically that's doing the algebraic manipulation of this expression, and at the end this is what I get, and this should be your answer. I hope that the discussion was helpful. Thank you very much.